All right, we're all set to go. So really quickly, before we go into any examples, I want to just go over what our different tests are. Let me clear this out so we can do things a little bit more easily. So it's all about the degrees of our rational function. We want to check and see what is the highest degree up top, what is the highest degree at the bottom. So for example, if you have something like 3x to the 4th plus 4x to the 5th minus 2x plus 1 divided by 2x squared plus 4x minus 7, we want to look at what is the highest degree up top. In this case, it's a 5. Sometimes it may not be in order, even though things should normally be in order. That might not always be the case. So we can see here the 5 is the highest degree in the numerator, and 2 is the highest degree in the denominator. So that's what we want to be able to do, is analyze the numerator, analyze the denominator, and see which one or what the different values are. And then we want to compare their size. So if the numerator is less than the degree of the denominator, meaning it's a bottom heavy function because the degree is heavier at the bottom, then we have a horizontal asymptote. So that means it's just a line straight across. And the equation of that asymptote will be y equal to 0. So that one's pretty easy to figure out, right? If you have something like x to the 4th plus 3x cubed minus 8 divided by x to the 5th minus 4x to the 4th plus 10, we see that the highest degree at the bottom is 5 and the highest degree at the top is 4. So then it's a bottom heavy function. So then your answer is automatically y equal to 0. You don't have to show any work. You can write off to the side bottom heavy function, and then that's it. Y is equal to 0. Now, when your degrees are the same, then we look for the ratio of the leading coefficients. So let's say we have kind of like a similar function, but we'll put 3x to the 4th plus 3x cubed minus 8 and 4x to the 4th plus 10. Okay. So there we have the same degree in the top and same degree at the bottom. And what we do is we look at the coefficient of those higher degrees. Now, sometimes, let's say maybe this is kind of switched around. This is 10 plus 4x to the 4th. That doesn't change the rule. The rule still says you take the ratio of the leading coefficients of the highest degree. So if this 4 is the highest degree in the denominator, then the coefficient that goes along with it, the 4, is what you're going to use to find your answer. So in this case, your answer would be y is equal to 3/4, because you take the ratio of the top and the bottom, 3/4. Okay. And then the last test was the oblique asymptote, which is when we have a top-heavy function. So the numerator is greater than the denominator degree, and that gives us the oblique or the slant asymptote. So rather than a straight line across horizontally, a slant asymptote is going to have like that diagonal direction to it. And so if we think about our parent functions, remember the parent function that looks like this. that is the equation y is equal to x. So your slant or oblique asymptotes are going to be some variation of this parent function, because that's what our slanted line looks like and how we can write it with that equation. We may have more of a slant, less of a slant, or it could be shifted upwards or downwards. So that means we're going to have some kind of transformation of this function as our slant or oblique asymptotes, meaning maybe it's going to be y is equal to x minus 4. So this diagonal line is just shifted down 4 and looks like that. Or maybe its slope has changed and it becomes 2x plus 1. So then we have a slope of 2, it's a little bit steeper, and then it's shifted up 1. So maybe instead it looks a little like that. Okay, just kind of a rough estimate. But that's our slant asymptotes. And so to find those asymptotes, we have to actually just divide our rational functions. Our rational functions are fractions, which is just division, right? You take the top divided by the bottom. So we, in order to find the equation of those slant asymptotes, we just do straight up division. It's your choice, well, sometimes it's your choice to be able to do synthetic division, but if you can't do synthetic division, then you would just go ahead and do straight long division. But you can always just go for it. If you like long division, just crank it out. There you go. There, that's how you get your slant asymptote. If you have any questions, please let me know in the group chat. Maybe you came across something in the play pause it video that you want to ask about. So please feel free to type it or just ask. But I'm going to do these 2 examples here just really quickly. So we're trying to decide if it's a horizontal or oblique asymptote. So we know there's only one time where we'll have an oblique asymptote, and that's if we have a top-heavy function. And if I look at the degrees of this function, the highest degree is 1 up top and 2 at the bottom. So this is a bottom-heavy function. So I know it's going to have to be horizontal, and bottom-heavy means y is equal to 0. Easy as that. Bottom heavy, automatically y is equal to 0. And we know it's going to be horizontal right at y equal to 0. So with this next one, because it's broken down, we know that the highest degree in the numerator is going to be what we get when we multiply those two, because x squared is the highest degree here in that trinomial, and x is the highest degree in that binomial. So when you multiply them, it'll give us x cubed. So we know x cubed is the highest degree up top, and x squared is the highest degree at the bottom. So this is a top-heavy function. So top-heavy means we know it's going to be oblique, and it also means that we're going to have to divide. So when it comes to horizontal asymptotes and oblique asymptotes, the nice part about this is that it doesn't really matter if you use the original function or if you use the simplified form of the function, because it still maintains that same ratio, so you still end up getting the same thing. So we have to decide what we want to do. And just by looking at it, I know that if I leave it like this, I'm going to have to do long division, because I have x squared plus 2x minus 3 in the denominator, which is not in the form for synthetic division. So I want to see if I can try and simplify this so that I can try and do synthetic division. So to simplify it, I need to factor. This will become x plus 2, x plus 2. And in the denominator, we have x plus 3 and x minus 1. So x minus 1 cancels out. And that leaves us with the x plus 3 in the denominator, which was my hope, so that we can actually do synthetic division here. So this is going to be x squared plus 4x plus 4. And we can go ahead and do synthetic division now. So with the synthetic division, remember we want the -3 in the little square, and then we look at the coefficients, 1, 4, 4. And then we go ahead and bring down the 1, -3, subtract, we get 4 minus 3 is 1, times -3 is 1. Now, if you were to write out your answer for this, we would always make sure we go down a degree, and so you would probably say 4x, I don't know where I got 4 from, x plus 1 divided by x plus 3. But actually, in this case, when we are finding the slant asymptote, the remainder is not part of your solution. It's only going to be everything else. I'm not going to say the first 2 terms because sometimes it may be 3, just kind of depending on your solution. But what I will say is the remainder does not count, everything else does. So in this case, our equation would be y is equal to x plus 1. So it's that diagonal line, and it's just been shifted up by 1. Okay. Please let me know, are there any questions on any problems? Would we like to see more examples? Or we can go ahead and I can post the worksheet and you can just try examples on your own if you feel ready. The worksheet is going to be involving everything that we've covered so far, so holes, vertical asymptotes, zeros, y-intercepts, and now these horizontal and oblique asymptotes. So let me know if you have any kind of preference. I'm going to go ahead and start posting the worksheet, but if you have any questions, I'm here to answer them. So for this worksheet, it has graphing on it. So don't worry about graphing just yet because we haven't gone over it. That's going to be over the weekend. You'll watch a video on how to finally graph it. But I do want you to practice finding all the different characteristics. So that's what you're going to work on. So you don't have to graph, but you do have to answer everything else on the worksheet.